Hi, thanks for joining us today. Today we'll take a look at deploying containerized applications faster and more reliably with Azure Red Hat OpenShift. My name is Oren Kashi. I am a product marketing manager at Red Hat, and I'm joined today with my colleague Ahmed Sabur, who is a product marketing manager at Microsoft. So let's get into it. So, first question, why Red Hat at Microsoft? And as Satya Nadella mentioned at Red Hat Summit last year, being that Microsoft has embraced open source and Red Hat is also known as the open source company, it's a natural fit for both of our companies to come together and really deliver what's best for both of our customers. As over 95% of the Fortune 500 use Microsoft Azure, and 100% of the global Fortune 500 companies in these industries use Red Hat, it is a natural fit for us to come together and to utilize our synergies to bring a complete solution to our customers like Azure Red Hat OpenShift. So what do we give you, right? So I like to think about this as kind of coming into three areas, like the more. So more than just Kubernetes. So while downloading and installing Kubernetes isn't all that hard, but getting it to a point where it is ready for a enterprise to run production grade workloads is another story. There are a number of things that need to be pieced together, need to be tested, hardened, and set up for operations. And this is in addition to other software projects that one may want to add, things maybe like Calico or Istio or Prometheus. And each one of those has its own skill set, its own community, its own release cadence to further complicate it a bit. More than software. So we deliver a standardized implementation of OpenShift Container Platform using best practices that includes the additional infrastructure services and operational processes that go along with that. Therefore, it makes it easier to maintain and also makes it easy and quick to get that enterprise-grade cluster up and running. And lastly, more than managed. And this is just a bit of a differentiation here in that the level of management differs with Azure Red Hat OpenShift. The word managed is used a lot in the industry, but we actually manage the entire stack of your cluster, everything down from the infrastructure all the way up through the application, including any sort of upgrades or patching that may have to go along with it. So if one was to go down the Kubernetes route and doing the DIY route of Kubernetes, it is not necessarily a simple thing to do. We see a lot of bullet points up on the slide here, and this is each one of these is an activity that somebody's going to have to go through at some point. With some of these, particularly in the operate column, are going to be more repetitive and cyclical and kind of like day two operations. So that's just taking Kubernetes, right? And just taking upstream Kubernetes to get that up and running. But on top of that, you're going to add other things too, right? You're going to want to add some other open source projects. Maybe you want to do something with cluster networking. So you might want to add Calico in there, or maybe you want to do like a service mesh like Istio or Prometheus. And each one of these is its own open source project. It has its own skill set that goes along with it, its own tooling, its own risk that goes along with that as well. So you'll really end up in a position where you have multiple plates that you're spinning in the air, and each one of these plates are different. And by the same token, when we look at using public Kubernetes or public Kubernetes services, really what you're getting is you're getting the green box in the middle, which is Kubernetes, right? But you're going to still want to add other services to that. You're going to want to add things like logging, for example, or a container registry, or maybe monitoring or CI/CD. And generally, if you're going to be using one of the public cloud Kubernetes providers, you're going to be probably using one of their public services as well. So those usually come at additional costs that need to be considered. But with OpenShift, what we do is we take all of those services, all of those tools, including Kubernetes, and we go through defect remediation, we do performance fixes, we harden it, we validate the integrations that go along with that, and we package that nicely into one product, into an OpenShift release. So it makes it easier for you to be able to know that you have a working platform and not have to invest in cycles to kind of patch the platform and plumb the platform together. So why would someone want a managed OpenShift service? And I think this kind of comes down to a couple of different areas. Firstly, we're talking about quick time to value. So in traditional IT organizations, the amount of time that it takes to get resources is probably something in the days to weeks time frame. I've even had one customer where it was months, and we can talk about that differently, but think about what that means. But if you're going to take days to weeks to be able to just kind of start putting the platform together, then it's going to take some time to put the platform together. So think about how much time is invested in just trying to get hands on keyboard, right? Before you get hands on keyboard to start innovating. By this token, it also increases your efficiencies and operations. And what I mean by this is that being that you don't necessarily now have to invest in resources to stand up the platform and to operate the platform, you're better able to invest those resources into things that matter to the business, things that matter to your underlying value. Instead of focusing on the plumbing, focus on the innovation. For most of our customers, really building a platform is not the end goal, right? That is not the business that they're in, but rather the platform functions as a means to an end. It functions as a means to make their applications more scalable or more maintainable. So the value is more in the applications that are on there, and that's where most of them would really like to focus on. This is enhanced further by our 24/7 support that comes along with it. So we do offer a financially backed 99.95% uptime SLA. We take care of all the upgrades and updates with zero downtime. And we also do proactive monitoring on the clusters. So we'll start to notice if there's any sort of service degradations or high resource consumption to stave off the potential for any issues. But nonetheless, should anything come up, any questions or any issues, you can always open up a support ticket 24/7. And lastly, this is all enhanced by the flexibility that you have in how you want to consume it. So whether you need a cluster for 1 hour or whether you want to commit to 3 years and leverage the most amount of discount, really the choice is yours and the same experience throughout. Okay, and kind of just comparing the two, right, in just Kubernetes or public cloud Kubernetes with Azure Red Hat OpenShift. Azure Red Hat OpenShift is purposefully engineered together. As we see the stack on the left, we see that all the components have been tested, have been integrated, and most importantly, are supported. So that top layer over there, the support and operations, flows through the entire stack. So whether there is an issue with the infrastructure itself, whether there's an issue on the platform, whether there's an issue at some point with one of the services, maybe service mesh or monitoring or your logging, or even at the application layer, if you're using one of the UBIs, then you'd get support for that as well. And that all of that is included in the costs. When you're looking at just Kubernetes or Kubernetes as a service offering, it's, you end up getting more of a managed control plane. You get the infrastructure, but then you have to add the services on top of that. So those top two layers start to become more of an a la carte offering. So which public service are you going to consume from the cloud provider? You're going to use the logging service that comes along with it? Are you going to do your own logging? And then the support and operations is something that you're going to have to keep in mind as well, because most likely you'll have to keep some resources to maintain the cluster, to monitor the cluster, to make sure that the integrations are done correctly. And in addition, each of these services are supported independently. It's its own service, it's its own offering from the cloud provider. So moving on, let's talk a little bit more about Azure Red Hat OpenShift. So as I was kind of mentioning and talking, Azure Red Hat OpenShift is a jointly engineered, jointly operated, and jointly supported offering by both Microsoft and Red Hat. This allows you to interact with whichever company you'd like to in terms of seeking support. You are able to scale as you need. So you could pay as you go for your cluster, for additional resources, or you can commit for the longer term. You're also able to leverage your Azure monetary commits. And as I mentioned, this is further enhanced by just the level of support that you get. So you do get that SLA, you do get the 24/7 support. And also we are compliant with many of the leading industry certifications as well. So how easy is it to get a cluster up and running? Pretty much as simple as this, right? So you'd run your command in the CLI, it'll go off, do its thing, and what's going to happen is it's going to spit back to you a JSON object that is going to contain all of the information related to your cluster. Now, granted, it's not as fast as in the image here. Maybe we can work towards that, but you'll really get a full cluster up and running in about 30 minutes. Some of the features that are inherent to Azure Red Hat OpenShift with OpenShift 4, you do get full cluster admin out of the box. We do support private clusters. So if you want your cluster to not be accessible over the public internet and only through internal means only, that is an option that is available, and we can configure a cluster like that. We can deploy into existing VNets. We do support cluster auto-scaling, so you can ensure that your cluster has the resources it needs when it needs it. And we also support multi-AZ clusters as well. Being that it is OpenShift 4, we do support operators. It does come with all the great productivity tools that OpenShift comes with. And as I mentioned, it is compliant with many of the industry-leading certifications. So now we're going to go through a demo. My colleague Ahmed is going to take you through a demo about deploying a multi-tier application to an already existing Azure Red Hat OpenShift cluster. The front end is deployed from a pre-built Docker image, and the back end is deployed from source code that is hosted on GitHub, and it talks to a MongoDB database on the back end. Ahmed, please get started.
In this demo, I'll take you through a quick run around of features that make Azure Red Hat OpenShift a great platform for container-based and cloud-native applications. The first thing you would want to do is to log into the web console using the username and password that were generated when the cluster was first created. You will be presented with a console. This console has two distinct views for the administrator and the developer. Since we're deploying an application, switch to the developer view and create a new project. A project is a Kubernetes namespace that you can use to host multiple deployments together and apply certain permissions on them. The first component we're going to deploy is going to be a simple pre-built Docker container that's hosted on a public repository. I'm also going to uncheck the option to automatically create routes because I want to show you that option later. Finally, I'm going to apply a few labels to this deployment. Labels help identify and categorize which components form which aspect of the application. This is what you need to do to get a container image deployed to OpenShift. This should work with any container image that follows best practices, such as defining an expose port, not needing to run specifically as the root user, and having a single non-exiting command to execute on start. Notice that OpenShift automatically picked up the expose port and created a service force. You can manually scale the number of replicas, and you can also set up horizontal pod autoscaling accompanied with the machine autoscaler and the cluster autoscaler to make sure that the cluster always has the resources to run your application.
Because this Docker container exposed the port, OpenShift automatically created the service. Here you'll see this is only accessible within the cluster. While services provide internal abstraction and load balancing within an OpenShift environment, sometimes clients outside of OpenShift need to access an application. The way that external clients are able to access applications running in OpenShift is through the OpenShift routing layer, and the data object behind this is a route. The default OpenShift router, HA proxy, uses the HTTP header of the incoming request to determine where to proxy the connection. Now that the route has been created, you should be able to access the published service on the internet. Now let's review logging. OpenShift is constructed in such a way that it expects containers to log all information to std out. In this way, both regular and error information is captured via standardized Docker mechanisms. When exploring the pod's log directly, you are essentially going through the Docker daemon to access the container's log through the OpenShift API. When your application consists of only one pod, and it never fails, restarts, or has other issues, these ways to view logs may not be so bad. However, in a scaled-out application where pods may have restarted, been scaled up or down, or if you just want to get historical information, these mechanisms may not be sufficient. Fortunately, OpenShift provides an optional system for log aggregation that uses Elasticsearch, Fluentd, and Kibana, EFK. This logging stack can be installed as an OpenShift operator. OpenShift provides a number of operators that are community provided or provided by Red Hat or provided by other partners that enable you to add functionality to your cluster. These operators are installed through the Operator Hub. The Operator Hub lists a number of these operators that are published by the marketplace or by the community or are either Red Hat certified, and they span across multiple categories from AI and machine learning, application runtimes, databases, and more. Now that we have the front end deployed, we're going to deploy the backend service, which is developed in Java, and it exposes a REST endpoint to the visualizer application. The application will query for national park information, including its coordinates. The data is stored in a MongoDB database. Earlier, we deployed a pre-existing image. Now, we will expand on that by learning how OpenShift builds container images using source code from an existing repository. This is accomplished through source to image. The application is hosted on a GitHub repo. As soon as I provide the source of the GitHub repo, OpenShift detects that this is a Java application and chooses the Java builder image. Similarly, I'm going to deploy this using a deployment config, and I'm going to leave the automatic creation of the root to the application. Like we've done before, apply labels to identify this deployment configuration. And this time, this is going to be the national parks component, and the role of this component is the backend. As soon as I hit create, OpenShift is going to kick off a build. You'll see that OpenShift is cloning the Git repo locally, and then it's going to use the Java builder image to build a Docker container of that application, inject the source code, and then push it to the integrated Docker registry that is running on the cluster. After the build is done, OpenShift will also trigger a deployment, and you'll see that the pod is already running. We're now going to add both a readiness and a liveness probe to the existing national parks deployment. This will ensure that OpenShift does not add any instance to the service until they pass the readiness checks. This will also ensure that unhealthy instances are restarted if they fail the liveness checks. Most useful applications are stateful or dynamic in some way, and this is usually achieved with a database or other data storage. In this part, we are going to add a MongoDB to our national parks application and then rewire it to talk to the database using environment variables via a secret. We're going to use the MongoDB image that is included with OpenShift. In a real application, we would likely use a managed database, such as Azure Cosmos DB, to store your data. Now that the database has been deployed, it's time to pass the credentials of that database to the deployment. And the way to do so is that you can assign the secret that was created to the national parks deployment. This would copy the
credentials and the host name of the MongoDB pod that was created into the national parks deployment pods, allowing the application to query them and connect to the database. Now let's load up the backend service. This service has an endpoint to load data into the database. Let's do that. And then verify that the data has been loaded into the database by calling the all endpoint. And you'll see that you get a large JSON object with all of the national parks have been inserted. But if we go back and refresh the front end, no data is coming back. So how does the front end know which backend to call? It does so through service discovery by querying the OpenShift API. The front end application is designed to query the OpenShift API for routes that match type equal parks map backend. In doing so, service discovery is automated, and the front end is automatically wired to connect to the backend. So let's go and apply the proper label to the national parks route. We're going to add the type equal parks map backend label to the national parks route. Now that we've added the proper label, in theory, the app should be able to find the route. However, you'll see that it can't because it doesn't have permissions to query the OpenShift API in this namespace. In order for this to work, the default service account running the pod must have the proper permissions. To configure them, we're going to create a role binding. Let's just give it any name here. View would work. And the role would be view. And I'm going to grant this role binding to the service account that is running inside the workshop namespace. And that default service account is called default. All of the pods that run within namespaces run within this default account service account permissions. To trigger this change, I'm going to start a rollout so that this new permission is applied to all of the pods that are running in the parks map deployment configuration. Once you've done that, you'll be able to see that the application immediately was able to pick up the data and load back the national parks from the database through the backend service. So far, you've seen how to deploy an application through S2I and through a direct Docker image. Most Git repository servers, however, support the concept of webhooks, calling an external source via HTTPS when a change in the code repository happens. OpenShift provides an API endpoint that supports receiving webhook calls from remote systems in order to trigger builds. By pointing the code repository's hook at the OpenShift API, automated code build and deploy pipelines can be achieved. So in this case, I'm going to configure the GitHub repository to call the webhook of this national park deployment for every code change. Now, if I go and trigger a source code change by editing a file, for example, let's go and see what will happen. So I'm going to pick one of the models, one of the controllers that host my application, and I'm going to change the data that it returns. Once I commit, you'll see that immediately OpenShift picked up this trigger and triggered a new build. This build is going to be using the new source code that was pushed to create a new version of the application. After the build completes, a new image is pushed to the container registry, which triggers a new deployment. This deployment is deployed in a rolling configuration, which means there will be no downtime to the live production application.
Thank you, Ahmed, for that wonderful demo. It was really interesting to watch and see how easy it was to deploy an application to Azure Red Hat OpenShift and really see all of the components come together. And I hope that our viewers found that interesting as well. So in wrapping up, I'd like to just call your attention to a couple of links and resources that we have. If you'd like to learn more, or if you'd like to try on a hands-on workshop and doing it yourself, or the documentation or any feedback about the service, we do have the relevant links up on the slide here. So I do encourage you to take a couple of minutes, come visit us, interact with us, let us know your thoughts, and hopefully this will help you along your container journeys as well. So thank you for joining us today.